Hello, my name is Vasilios Kosmakos. Today is January 19th, 2022. Who do I have the pleasure of speaking with today?
Bob Knight.
Nice to meet you, Dr. Knight. So if you can kind of just give me a little bit of your background, right? So who are you? What do you do as a career?
I am a professional wetland scientist, or environmental scientist, I guess. My career was primarily in consulting, doing the design of treatment wetlands, like the Sweetwater wetland and other wetlands around the world, and wrote a book on treatment wetland design. I did my doctoral research at Silver Springs, Florida, and that initiated a springs interest that I followed much later in my professional career. I was hired by the various water management districts and the Department of Environmental Protection to do their springs studies for them when the state had a springs initiative, it was called. And then when they stopped that program, I started the Florida Springs Institute in 2010. So I'm now the director of the Howard T. Odom Florida Springs Institute that's in High Springs, Florida.
So discuss a little bit about the organization that preceded the Florida Springs Institute that you just mentioned.
When I graduated from, I actually conducted research between degrees, college degrees. I got my bachelor's degree at University of North Carolina as a zoologist. I then worked for a year doing aquatic research at the University of North Carolina. And then I came to then I went to work in South Carolina at the Savannah River Ecology Laboratory for 4 years, studying the effects of heavy metals in stream ecosystems, mercury and cadmium in particular. And then I came back to the University of Florida, back to the University of Florida, because I'd been here one semester before that to work on my PhD. And that was in 1977. I finished my degree program in 1980 after the study of Silver Springs. And I then took a job as an environmental consultant with C.H. Tuam Hill, an international engineering firm, where I really applied the work of Dr. Odom in terms of using wetlands for water quality treatment. And so I did that for 18 years with C.H. Tuam Hill. During that time, I wrote the book on treatment wetland design. And when I left there, I went on my own and started a company called Wetland Solutions Incorporated. And that company, I managed and was the president for 17 years. And during that time, we designed the Sweetwater wetlands, and I designed treatment wetlands all over the place.
Oh, really?
Yeah, and actually a Sweetwater wetland in Tucson, Arizona as well, and numerous projects in California and Arizona and Oregon, but mostly in Florida and the Southeast, South Carolina and Florida. And in 2017, I sold that company to my employees, and I essentially retired full-time as director of the Florida Springs Institute. I managed both the Springs Institute and Wetland Solutions up until 2017, but since then I've just been managing the Florida Springs Institute.
So discuss your work with Sweetwater wetlands. I'm a huge fan of that area. I'm there all the time. So tell me a little more about the process of why the need was, why it had to be created, and kind of work with that.
It's a very interesting project, a very long-term project. The original idea to put wetlands out there to treat the wastewater from Gainesville was offered by Dr. Jack Yule's students, a couple of students from Europe, who he put to work studying the Sweetwater branch, the creek that drains Gainesville is where the effluent from half of Gainesville is discharged once it's treated. But it's not treated very much, especially back in the 70s. And so they proposed and studied the water quality benefits of when that water spread out on the prairie, what was happening. But that fit right in line with what Howard Odom had done in the Cypress Dome study back in the mid-70s here at University of Florida. He first pioneered the use of natural wetlands for treating wastewaters. And when I went into consulting in 1981, the first project I had was to design a treatment wetland, to design and permit a treatment wetland for that Sweetwater branch discharge. 1981 was a long time ago. At that time, the state park was not willing to devote part of the prairie to being a treatment wetland. The water was in a canal. It was going right to the sinkhole, right into our drinking water supply without any additional treatment. It was really pretty strong wastewater effluent at that time, with high levels of nutrients. And it was over the next 20-some years that the city periodically upgraded that wastewater treatment plant. And I prepared a conceptual design in 1981 that wasn't followed. It just went on the shelf. And but by the middle, about around 2010 or so, the state of Florida implemented a basin management action plan that included Paynes Prairie that said the city had to remove 200,000 pounds a year of nitrogen from the stormwater and wastewater that was going onto Paynes Prairie in Alachua Sink. And so they came back to the project. I was the president of Wetland Solutions. I'd worked on the project from the beginning. I was enlisted as one of the project team. Wetland Solutions worked directly for the city of Gainesville, and then the engineers, the lead engineers, Jones Edmonds, worked separately for the city of Gainesville. They did the hard design. Wetland Solutions did the process design, which was determining how the wetland needed to be built, how large it needed to be to get a certain amount of nitrogen removal, and what's the best way to design it, because we've been doing that for decades. And that's how the project got designed. It was all designed and constructed by, I think, 2015 to 2017, maybe it became operational. I don't remember the exact year, but it's now one of the most popular parks in the area, as you know. And it's just a wonderful legacy to leave. In my treatment wetland work, like I said, I did projects all over the country, but I think Sweetwater was the culmination of at least my own work in terms of knowing how to design treatment wetlands and making sure a project was going to really meet all the requirements and exceed those, which it has, and because of the wildlife benefits associated with it. So
discuss kind of your path from kind of treatment of wetlands right to your interest in Florida Springs. What specifically kind of led to that?
Well, I'm an environmental scientist. I worked on at least 200 projects when I was in consulting, over 200 projects, probably 300 counting Wetland Solutions too. And so I worked on every kind of water quality project associated with the environmental issues that you could. And once again, I worked around the world. So I saw every type of wastewater, every type of stormwater, all the natural issues related to the wetlands that were being impacted. And my job for all those years was to try to mitigate and reduce environmental impacts from pollutants and from human activities of different types. And so that informed me about a lot of things. And then my earlier work on springs and my earlier work before that on streams receiving heavy metals, that's what brought it all together at the end of my career, really. I essentially retired in 2017. Since then, I've been working just purely on wetlands, on springs, and that tied it together, because springs are aquatic systems. They're polluted with nitrogen. They're being depleted by water use issues, and they're a very important resource. Florida has 10 or 11 million acres of wetlands. We have about 10,000 acres of springs and spring runs. It's the rarest habitat type in Florida, and yet we have more springs and spring runs than any other part of the world. We have over 1,000 artesian springs. And like I said, but if you add up the area of all those springs, as well as their spring runs, like the Silver River and the Ichetuckney River, it's only 10,000 acres in Florida. And that's, there's no other habitat that's so limited in Florida and so unique.
So I liken, the specialty of the Florida Springs with that almost like the Amazon, right? The stuff we have here isn't found almost anywhere else in the world in terms of how unique it is. Would you, speak a little bit more about that? So what makes Florida Springs particularly unique?
Well, they are a unique they're not a unique ecosystem. There are springs around the world. There are, thousands of springs around the world. There just aren't as many large springs in one area concentrated like they are in North Florida. There's 1,090 springs currently registered in the state's files. We're finding new ones all the time. People are bringing information about those. They add up to a historic flow of just the ones in Florida, not counting the ones in Georgia and Alabama and South Carolina, most of which are dry now. They have an average flow of over 10 billion gallons a day So that's a lot of groundwater coming out of springs. So what's unique about them ecologically is they're a clear water system. There are very few rivers in the world that are clear water. And clear water means sunlight can reach the bottom. And you can have very high rates of primary productivity because the two of the major things needed for primary productivity are light and water. And the third thing is nutrients. And our groundwater has the background levels of phosphorus and nitrogen are adequate for extremely high productivity. And this is what Dr. Odom showed many years before I started studying springs. I actually went to Silver Springs in 1953. At the time, Dr. Odom was studying it, but I was only 5 years old. So I saw it. I was impressed by it. And it hadn't changed much by the time I went there in the 70s. But by the time my kids had grown, I'd had them playing in springs their whole childhood. But by the time that they were in middle school, the springs were just getting worse and worse shape. So they are important to our economy. They're important to the wildlife that lives in them. And they have, I wouldn't say a totally unique ecosystem, but there's no other ecosystem that has all the qualities of springs, which is very high, under natural conditions, very high primary productivity, equal to agricultural fields, equal to tropical rainforests, equal to coral reefs. That Dr. Odom proved that. And the wildlife they do support, some of it is totally dependent on them, like the manatees are here in Florida, and certain fish and turtles and other animals are totally dependent on springs. And they produce about $1 billion a year of recreational impact in Florida's economy. So they're really important economically, but my interests are obviously the biota and the ecology of the springs, how important that is.
So kind of speaking of the biota and ecology of the springs, it's like a lot of these springs, right, the Ichthyophilus River have pretty unique endemic species. So I think in the Ichthyophilus there's a specific endemic snail population. What allows the springs to kind of harbor such a unique kind of endemic kind of like populations like that? Well,
part of the endemicism partly is derived from like the island biogeography. Geography is basically if you have isolated populations, then you get specialized evolution over time. And so the Ichthyophilus silt snail is one of about 5 silt snails around the state that are unique to different spring systems. Blue Springs has one, Volusia Blue Springs. And so those populations are isolated because there's only 10,000 acres of spring habitat in the state. So there's really no stepping stones other than through the rivers that are spring fed. And of course, the Ichthyophilus River goes into a blackwater river, which is the Santa Fe, which goes into Swanee. And actually, historically, the Santa Fe and the Swanee were predominantly spring water too. And that's one of the things that's changing. But that's one thing that creates unique species. But the thing about springs, it's unlike any other water bodies in Florida, is they stay the same temperature year round. And that gives organisms like manatees that absolutely can't have water less than 65 degrees during the wintertime, a place as a refuge. It also allows cold water species like striped bass a place to go in the summertime when they're coming up the Santa Fe River, or the Swanee River, the St. John's River, trying to breed in the St. John's River the way they used to do. They come up there and they have to go into the springs to stay cool during the summertime. So, and there are other organisms that come in the winter and some that come in the summer. So it's that constant temperature. Dr. Odom described them as they're what we call in science a chemostat. They're constant chemistry because the groundwater is not supposed to be changing. They're constant temperature. They have constant, essentially, light on a daily basis. That's the one thing that varies, but they are a lit system. So anyway, temperature and chemistry are very constant. That's not typical of other aquatic systems, any aquatic systems. Wetlands, rivers, they typically have dark water in Florida. They may dry up during droughts. Springs flow all the time. Constant flow is the third thing. Yeah.
And from my understanding, too, speaking more about the biota, the Florida Springs kind of harbor a lot of unique species of turtle. I think it's about a dozen or so, right? Would you care to elaborate more about kind of turtles and their kind of role in the springs?
Yeah, I don't think the species of turtles are unique in springs, but we have the highest diversity of turtles, I think, anywhere in the possibly in the world. It's very close, if not the top, in terms. It's like 25 turtle species here in North Florida, and they're not just in springs, but we have a lot of aquatic turtle species, some of which are pretty limited to springs, like the loggerhead musk turtle is a cute little turtle that's got a big head for eating those snails. Not the endemic and not the endangered snails, but the more common snails, the Goniopsis snails in the river. These turtles are adapted to eat those, and that's not an easy job for a small turtle. But yeah, so there we have some great turtle experts. I'm not a turtle authority at all. I've been with them on collections, but I'm not good at even identifying. But they are, some of our turtles are very dependent on springs for their breeding activities. And you'll see them come into the springs to mate. And also some of the springs actually fed our turtles when all the vegetation in the Santa Fe River died back in 2017 because of the dark water event after Hurricane Irma came through. And
so over the course of your career, right, what have been the most kind of dramatic changes in species composition, if any, you've seen?
It's mostly a depopulation, a decline in the number of organisms. I don't think there's that many extinctions that have occurred in springs, at least not that we know of. There are some very rare species of organisms in the groundwater itself, in the aquifer, and very little is known about those, so you don't know if they've gone extinct or not. Nobody's just found them for a long time. But the organisms that live in springs are generally not going extinct. What they're doing is their populations are plummeting over time because of the biggest impacts, the reduction of water flow in the springs, which flow augments primary productivity in springs. The more flow in general, you have more productivity, so you have more life support for wildlife. But then the other thing, the nitrogen pollution is also altering the springs. So I'm going to ask another one. I've lost that question.
Yeah, so let's kind of go back to what you were mentioning about dead stream flow, right? So that's obviously a really important part about the Florida Springs. Kind of, for someone that doesn't know anything, right, just explain that to us.
Well, let me give an example. Yeah, flow is important because flow is renourishing the nutrient content of the water continuously. If the water is stagnant, the nutrients that are in that water get acted on, go into biomass very quickly, and then become unavailable, and you really have a crash. You have a boom bust. In a spring system, you've got this flow that has nutrients in it continuously, and that the diffusion of those nutrients into the organisms, the plants in particular, is based on the velocity of the water, which is related to the flow. So that's probably the main reason that flow is important, is that it accelerates the incorporation of atmospheric oxygen into the water body because of the diffusion of oxygen. And springs can be very low oxygen, and it augments the uptake of nutrients by the plants, which then form the basis of the whole food chain. So that's really important. But for just an example of the depopulation of wildlife in a spring, when Dr. Odom studied Silver Springs in the 1950s, he documented the fish populations by visual counts. Springs are really neat to do research in because you can see the organisms, unlike most rivers. And so he documented how many mullet and channel catfish and all the other species of fish were in there. He had me redo that when I did my doctoral work there 25 years later, which I did. And the populations of those animals was down over 60% in that time. And then I had the good fortune to be hired by the state to go back and restudy Silver Springs in the early 2000s as part of the Florida Springs Initiative when I was a consultant for the state. And we restudied Silver Springs, and the populations, compared to Dr. Odom's numbers, were down over 90%. So that was just an enormous drop in fish population. Now, I've been studying Silver Springs ever since then through the Springs Institute. We go out and do fish counts pretty much annually. And what we're seeing is it took a long time for those numbers to start coming back. They have been coming up, but it's almost completely exotic species now. tilapia. Blue tilapia has just taken over the biomass of Silver Springs, which is an opportunistic algae-eating fish from the Middle East. Plecostomids came in too, but they boomed and busted. They're gone. They're not completely gone, but they're not nearly as many as there were. And I'm hoping the tilapia may do the same thing. The Fish and Wildlife Commission is going to be studying that. We're working together on studying that. But yeah, our counts just document this explosive growth over the last 7 years or so of the tilapia populations. Now, that hasn't knocked out other species completely, but the biomass of other species is still going down or is still low. It never really has come back up since we studied it in 2004 when we saw that there was a 90% reduction.
And are there any particular factors you can directly attribute to that?
Well, Silver Springs is terribly polluted.
Yeah.
It's lost up to 40% of its average flow. That's enormous. Silver Springs had the highest flow of any spring measured in the world, not just in Florida, but the world. It had an average flow from all the way in the 1800s of over 500 million gallons a day, 500 million gallons a day. That flow started declining in the 70s. By the time I studied it in 2004, it was down about 25%. We went back and restudied it with the Springs Institute about starting in 2010 to 2012 or so. It was down almost 40%. In 2012, Silver Springs, during a limited time, its flow went down to 1/5 of its historic average flow. So it's lost a lot of its flow. That can account for, and also its productivity has gone down over time. I directly measured that. Dr. Odom measured it. I measured it in the 70s. We remeasured it. We've been remeasuring it ever since, and its productivity has gone down, even though the nutrient levels have gone up 3,000%, 4,000%. The nitrogen levels have gone up.
And what causes a decrease in flow in the spring?
Groundwater pumping. Yeah. The only other use of groundwater is human use through groundwater pumping. Either all the water that used to recharge the Floridan aquifer, the limestone aquifer in Florida, under all of Florida, came out at the springs. That's the way, and that's where the springs got 10 billion gallons a day of flow. Well, we're now pumping, we're competing for that, for the whole Floridan aquifer. About 4 billion gallons a day on average is being pumped now, out of the whole budget of 10 to 12, 12 if you count the whole aquifer as the recharge. We're pumping fully a third of the recharge to the aquifer. We do that now. And that's on average. And of course, the recharge is much less during dry years. And so the aquifer falls much faster during dry years. And that's what happened in 2012. There was an extended drought. It got so bad, and the aquifer got so low that all the springs from Post Springs up on the Santa Fe River stopped flowing. There was no flood, not even River Rise, which is a giant, resurgence of the Santa Fe River, stopped flowing. And essentially there was no flow in that part of the Santa Fe River, and it just turned into a cesspool. Became just filamentous algae. You've seen the pictures, I'm sure, that John Moran took during that time. And that was happening gradually at Silver. Silver was always blue before that 2012 event, but John Moran documented it. The water was turning green by then because reduced flow and increased algae is a recipe for green or brown water.
And then so we're pumping this water out of our systems, right? Nestle, a huge kind of controversy over the last couple of years in Gainesville. Do you have any comments about kind of what they're doing or not particularly? Yeah,
and not so much Nestle. Nestle is just emblematic of the big problem. Big problem is other uses. The bottled water industry is on the order of probably less than 5 or 10 million gallons a day. We're pumping 4 billion gallons a day. That's 4,000 millions. So it's a drop in the bucket, literally. Now, all our water uses are a drop in the bucket, and we have very wasteful water uses. The majority of our water use is, a fourth of it is basically outside irrigation. So we're using groundwater, this precious, one of the most precious resources in Florida. I'd say after sunlight, groundwater is the most precious resource in Florida for life. for all kinds of life. And then we're using that for watering lawns, which is ridiculous. And then another fourth, well, almost a half is for agriculture. And agriculture is turning very unproductive lands into productive lands by getting free water and pumping a lot of it. And that explains a large part of the groundwater use is that's not being returned, because water that's pumped for agriculture generally all evaporates and does not recharge. Water that's pumped for, like, the city of Gainesville water system, and all the water uses in North Florida are groundwater, essentially 98% of the water use. So the water that Gainesville pumps, about 2/3 of that goes back to the aquifer. It recharges the aquifer through Paynes Prairie and Sweetwater Branch and Alachua Sink. And then it goes to our well field. So we essentially recycle our water to a certain extent. So groundwater pumping is the only explanation that makes sense for the long-term declines in spring flows. And that's controversial, because the state does not want to admit that, even though every hydrogeologist that's studied it says that. That's the only thing competing. The state has models that say, oh no, it can't be that much, it's got to be rainfall or something like that. And we, and as well as others hired by the state, have gone through the statistical analysis to look at the effects of rainfall versus the effects of pumping. And pumping is, you can separate the effects of rainfall out. Rainfall's primary input of water to the aquifer, so it's very important. But you can separate that out by looking at rainfall trends, and then you look at, is the water level still going down? Are the flows still going down? They are, in all the springs. And if you go to any connected spring system, the flow's going down now because our pumping is still going up.
So the way I see it, right, there's two kind of major issues, right? There's the pumping, right, but there's also the excess of nutrients, right? Mm-hmm. So and then agriculture, right, is largely responsible for that, and phosphate mining. So would you kind of care to talk more about that? So how do excessive nutrients affect the health of the springs? Okay,
all the springs that have been studied, nitrogen is the only issue really of concern. Phosphate is not making it through the aquifer into the springs, and which is really neat. Phosphorus is attracted to limestone, and apparently it's being absorbed by limestone.
Interesting.
There may be a day when we've fully saturated that capacity, and the phosphorus starts breaking through. But there are only a few springs that have elevated phosphorus, and it's usually explained by stormwater inputs, surface water inputs, and not groundwater inputs. The aquifer doesn't have high levels of phosphorus in it, but it has very high levels of nitrogen. So the background concentration, the form of nitrogen that's in the aquifer principally is nitrate, which is an oxidized, very low energy form of nitrogen. It's mostly oxygen. It's 3 oxygen atoms and 1 nitrogen atom. And it's very recalcitrant to change, except under certain conditions. And the concentrations of nitrate have been increasing exponentially in a lot of places, but we've graphed it from the earliest data in the early 1900s up to the present. The nitrate level concentrations in some of the springs, like Rainbow and Silver to a certain extent, are going up like a rocket ship. I mean, they're just continuing to go up regardless of what the state is supposedly trying to do to prevent that.
And how do we mitigate that issue? Is there anything that could be on the individual level? Does this have to be more structural at the state level? What do you do?
Yeah, I just finished a book called Saving Florida Springs, a prescription for springs health. It's just published this week.
Congratulations.
Well, it's a short little book, and I don't have a copy here to show you, but it basically, the recipe is very simple. The recipe is to put the public interest over the interest of corporations. And in Florida, that's not the way our political system is working currently. But it doesn't have to cost anything. All you need to do is put a cap on how much groundwater can be pumped, and a fee on all groundwater pumping to discourage. You don't even have to tell people not to pump. You just turn the price up, and people will stop pumping. Agriculture, they get, on average, I think it's like, oh, darn, I was just looking at the numbers. $18 for every 1,000 gallons of free groundwater they get. They get $18 of crop production, which in a year, oh God, I'm sorry, I just was going over the numbers. I'm in a forum tomorrow with Nathan Crabb of Gainesville Sun, and I'm going to be putting those numbers out tomorrow. But there's a tremendous benefit from getting your groundwater for free. And right now, groundwater is free. The people that pay for it are the people in cities. They're paying $5 a thousand gallons. The farmer's paying 5 to 10 cents a thousand gallons to pump the water. And that's it. That's just the cost of the electricity or the diesel fuel to pump it. And so they are able then to raise a crop every year instead of losing a crop every 2 or 3 years. And they can go on the worst soils and do that. So the way to stop that is to put a cap on the amount of groundwater that can be pumped that is realistic. And we've determined that through science. We know those numbers. We've worked with the numbers coming out of the water management districts in terms of minimum flows and levels in our own research. And we know that we shouldn't be reducing the average historic flows by more than 5% if we want to preserve the ecological integrity of the springs. That means we need to cut back our groundwater pumping by about half, which is a big deal. That's 2 billion gallons a day. And a lot of farms are dependent on it now because we've been giving away these permits like candy for 30 years, 40 years. And so, but that's what needs to be done. And if they won't stop on their own, when there's a cap, first of all, everybody's permits get reduced. All you have to do is say, I'm sorry, we give you a permit for 1 million gallons a day. We're going to cut it down to 500,000 gallons a day. And there are 30,000 of those large permits. So that's all you have to deal with is 30,000 permits. And private users, the amount of water that's used is insignificant. You need to cut back on the city permits too. Gainesville's permit is twice as big as they need. Jacksonville's permit's more than twice as big as they need. So some of the big city urban permits need to be cut back too.
So can I elaborate on that a little bit more? They're twice as big as they need. What do you mean by that? In terms of just use or? Yeah,
because they put no restrictions on people's watering, landscape watering. And Gainesville and Alachua counties really taking a lead on that now compared to other communities. But it's not common throughout the state, and the state is trying to legislate that against local governments from taking steps like that. But the city of Gainesville actually has tiered rates on water use. If you live in town, up to a certain number of gallons per day, you pay a rate of $4 or $5. And if you take twice that much water, you're paying a rate of $10 or $15 a thousand gallons. So you can discourage water use that way. But the problem is the state allows all those individuals to avoid those rates by putting in their own well. Anybody can put a well in their yard, which is crazy. So that's why you got to limit the total amount of groundwater use, but then put a price. Every well should be monitored. There's only about 900,000 wells, groundwater wells in the state that are in the Springs region. It's based on my estimating. And but every one of those wells should have a water meter on it, just like every house does in town. And that meter needs to be read every month, and there needs to be a charge related to how much water is used. So to discourage people from wasting that water. So people still need water, right? Well, they first of all, they don't need the kind of landscaping they have now. They can have springs-friendly yards is what we call them. But the other thing is you can use rain. We have a lot of rain in the state. You can collect rain in rain barrels, but even smarter than that is to collect rain in cisterns, which is a lot of the world uses cisterns in the tropics, everybody has a cistern. That's what we should have in Florida because of the amount of rain we have. And just by having a relatively small cistern, every house in North Florida at least would have enough water to get through dry years and wet years without having to pump any groundwater. But groundwater should be reserved for human consumption where it's necessary. Rainfall should be used for everything else. Agriculture should be totally dependent on rainfall, and outside landscape irrigation should be totally dependent on rainfall. So either storing rain in reservoirs, storing it in cisterns, putting a price on it so people won't use as much for groundwater. And it's the same way for the nutrients. We need a cap on the total amount of nitrogen that's going on the ground. We just finished a project called the Blue Water Audit that estimated the total nitrogen that's reaching the ground surface in the Springs region of Florida, which is about almost 2/3 of the state, feeds fresh water to the springs. is about 300 or 400 million pounds of nitrogen a year. About 40 million pounds of that is making it to the aquifer. So about 10%, 15% is making it to the aquifer. And that's the nitrogen that's currently contaminating our aquifer, so that we have numerous areas that are above any kind of safe drinking water standard. And 80% of the Springs region, now the aquifer is so polluted that it's above the Springs standard for nitrogen. So we need to cap the amount of nitrogen fertilizer and nitrogen uses that go on the ground and put a price on nitrogen. That's all we have to do is those things. Those are legislative possible things. They'll be lobbied against because there's people making a lot of money of not doing that, but they're easy ways to solve the problem. The existing septic tanks we have 2 million septic tanks in Florida. They are a big problem in highly populated areas like around Wekiva Springs, around Silver Springs, around Rainbow Springs. Septic tanks are a big issue. They need to be reconnected. They need to be connected to central sewer when they're really at high densities. And there should be no more septic tanks going on small parcels.
So
those things would solve the problem almost with no money spent.
And so I also kind of understand how kind of connected these kind of bodies of water are, right? So we have our aquifer, right? We have our Florida springs that the aquifer emerges from. Then we have our rivers that these springs lead into, and then the rivers lead into our bays, right? So is there a connection between, for example, the large kind of red tide blooms that we've seen in Tampa Bay and elsewhere, and kind of the successive load of nutrients that we've kind of been seeing as a result of what you just said?
Yeah, I'm sure red tide at the levels we're having it are related to nitrogen pollution coming off of the state, human pollution. It's nonsense that they've got actually some senior people in the Fish and Wildlife Service and others saying that red tide has nothing to do with human activity. We know it's related to nitrogen. If there's more and more of it. The Suwannee River drains a very large area of agricultural production. And it's got almost 300 springs along it. And so the nitrogen that's coming into the river, we've been studying this very intensely for a number of years now. And the nitrogen that's coming in, 95% or more of it is coming directly from spring flows into the river. And the amount of nitrogen in the river now is averaging 5,000 tons a year of the element nitrogen. Not nitrate, but I mean nitrogen as nitrogen is in the river on average. In some years, 7,000, 8,000 tons. And the background would be less than 500 tons. This is a 90% increase in the nitrogen load in the Suwannee River, where all that goes into the Gulf of Mexico.
And the nitrogen load, right? Excuse me. The nitrogen load in these springs, right, result in kind of this toxic kind of cloud of green and blue algae, right, that you've kind of mentioned earlier, right? It's like, why is that problematic for the things for the plants and animals in the springs? What exactly does that do?
Well, the productivity of the algae, for the most part, is not useful for the rest of the food chain. Nothing wants to eat the algae, the noxious algae that grows in springs, this long filamentous algae. There'll be some organisms that can eat it to a certain extent, but it's not productivity that is magnified up the food chain at all. And that's why you don't get more fish, and you don't get more manatees and things like that when you have a lot of algae. Well, you get a lot less of those organisms. The algae actually smothers the healthy submerged aquatic plants, and the nitrate may actually be toxic to those plants, although we haven't proved it yet. I'm quite sure that there's a strong relationship there that will be found eventually. So we've lost the native plants in many springs, the springs that are most susceptible, and that nitrogen fuels the algae. And there's controversy about that. I mean, there's people you can review that'll say that the nitrogen coming out of the springs isn't feeding the algae. Well, it definitely is, and multiple lines of research show that the nitrogen that's in the springs is contributing to the prolific increases in algal production in the springs.
And from my understanding, the algae, this kind of bad algae essentially changes the water chemistry of the springs as well. Is that incorrect? That's
not so true. For the most part, the algae doesn't affect the water quality, but some algae do release toxins. Okay. Yeah. So all sorts of organisms release toxins of various sorts. A lot of upland plants do, but that the toxins that people generally are interested in are ones that affect humans, and so there are some cyanobacter toxins that come out of certain types of algae. That's not hurting most of the things in springs as far as we know. What's hurting them is that the food chain has changed. It's like you go to Publix to get food. Maybe not Publix, or maybe it's Winn-Dixie, but you go to a grocery store to get food, and you buy a diversity of foods, right? And it's like going to the store, and all that diversity is gone, and all you've got is spinach. But I shouldn't even use spinach. I should say something that's inedible, some green that you don't like,
Kale.
Spanish moss. Say Spanish moss is the only thing that's there, and you're not going to eat that stuff. But it's green underneath if you scrape the gray off. I mean, that's what it is for the organisms that live in these springs and rivers. And, that's the important. We put everything in terms of human benefits. I tell you, the springs are really hurting. And we got to be thinking about the rest of nature. And we got to be thinking about the bigger picture here, which is protecting everything that lives on the earth and not just humans. We're not having much of a problem with our population, while a lot of other types of things are. And so I always say, when somebody's pumping a lot of water, you save some water for the fishes because they need the water.
So kind of discuss the Spring Institute, right? Why did you start it, or why was it started, and what does it do? What exactly does it do to kind of help solve these issues we've been discussing?
Well, the Springs Institute was founded to basically protect springs through education and science. And that's essentially what we do. The Springs Institute, through me, was quite a strong advocate about many of the things going on in the state early on. And to sort of eliminate the potential conflict of interest that creates in terms of people trusting the science we do, we spun off the Florida Springs Council, which is now the advocacy group for springs. Ryan Smart is the executive director of the Florida Springs Council.
I interviewed him.
Yeah. Okay. Yeah. And I was a member of that. Like I said, I helped start it, but I decided to back off from that and focus on education and science. And since the very beginning, I can say we do unbiased science. We don't pick the data. We don't cherry pick the data to show that springs are in trouble. We just go out and measure the springs. That's what I've done my whole career. That's what I did for the state. I did it for the Department of Environmental Protection. I did it for Fish and Wildlife. Did it for all the water management districts. And they trusted me to give them good science. And that's still what I'm doing. And I have a very small number of employees that do that work. I just supervise the operation as a volunteer. I don't get paid. But this needs to be done. That's why the Springs Institute was set up, because it's something that needs to be done that the state is not doing anymore. And the state did it for a while through the Florida Springs Initiative, but they dropped it when Governor Scott came in, as soon as Governor Scott came in.
So discuss the Florida Springs Initiative. You mentioned that several times.
It started in 1999, really, because Jim Stevenson, who is a very high figure in the state parks program, took the governor, Jeb Bush, on a canoe trip, he and the Secretary of DEP, on the Ichtucknee, and said, and Jim had recognized the decline in the springs for years. He was basically very active in acquisition of springs into the state park system. So by the early 1990s, he had started a working group for the Ichtucknee, and then started one for Wakulla Springs after that. And then he started the Springs Initiative. He helped start the Springs Initiative. Jeb Bush did it. He's the one that started it. And that set up a task force, the Florida Springs Task Force. Jim Stevenson was the head of that when it started, but it incorporated technical people from different agencies as well as the public, including Wes Skiles, the famous cave diver. That task force made all sorts of recommendations, produced a wonderful report in 2000, 22 years ago, it's hard to believe, that said we need to be doing this, this, and this to save the springs. And that their work got more and more diluted. The next governor, Charlie Crist, kept funding the Florida Springs Initiative, and they were doing projects, but only $2 million a year projects, and including the studies that I was doing and others were doing. And by 2007, they had issued a second version of that report that had stronger recommendations, and it never saw the light of day. It was canned by the state. And then by 2010, when Rick Scott came in, they just abolished the whole Florida Springs Initiative, including, I was working on a contract. I was directing the Wakulla Springs Working Group at that time, and somebody else was directing Ichetucknee, and they stopped all state support for the springs until we started raising a big fuss about that over the next few years, and they started putting money back into springs protection. And now the state spends $50 million a year or more on springs protection, but they don't have a task force. They don't take any recommendations in terms of how to spend that money, and they spend it on pet projects. And I think an awful lot of it's going into the wrong pockets, and it's definitely not helping the springs.
So you mentioned that the second report was under
2007. Yeah, that was still Charlie Crist's time. But it became very politically difficult. The Associated Industries of Florida, which is made up of all the polluting industries in Florida, are the strongest lobbyists in Tallahassee, and they write the laws now. That's literally who writes the laws.
And then contemporarily, right, under DeSantis, right, it's like you did mention that the budget did increase pretty substantially, right, to $50 million. I think it's looking better or worse. I mean,
no, that's the appearance of doing something.
Yeah.
So you're taking taxpayer money to solve problems that are being made by a very few number of industries. Very few, a very small number out of 22 million people in the state. It's in the tens of thousands of people that are profiting from all these things that are killing our springs, killing our Indian River Lagoon, killing our manatees. It's a very small number of people profiting from it. It's not the public. And then they take the public money and say, we're going to do springs protection to undo these problems. The money doesn't get spent well. There's no follow-up on it. There's no recording of how successful it was in terms of reducing nitrogen load. It's totally based on estimates at the beginning. It's as close to criminal as you can get. It is criminal as far as I'm concerned to spend the public's money unwisely and then to tell the public that you're doing something to make things better. It's unbelievable. And you read that every day in the paper. I mean, it's not just me saying that. It's a lot of people that don't have a vested interest in it that are speaking out about these issues.
Absolutely. And then just because I know you have to get going soon, the final question kind of being, what do you want people to know, right? Any final thoughts? What do you want the world to know about what you're doing? For instance, thoughts, whatever you want to go off your chest.
Well, I've historically said that the public has the ability to change these things. And public awareness and public education and public outrage has always changed things. But the political powers we have now are taking that away by reducing the public's ability to vote honestly in an honest election. So I'm not sure there's anything you can do about it. But that doesn't mean you shouldn't stop trying. And I tell you, if we get 1 million people showing up in Tallahassee outraged that their money is being spent to pollute the Indian River Lagoon and to pollute the Swanee River and to create red tide in South Florida, and drive away all the tourists down there. If those 1 million people would go to Tallahassee, things would change. But they don't change because the legislators, they feel like they are untouchable. And I meet with them. I've gone up there. When I was a strong advocate, I was going up there to Tallahassee regularly and trying to work with these people and working on the early stages of legislation that then was completely altered by the time it finally came out as the Springs and Aquifer Protection Act of 2016. I mean, I've seen how the sausage is made, as they say, and it's very alarming. And the public is going along with that, and so. It takes something big to upset that apple cart, and it's very easy to stay with the status quo, but the status quo is getting worse and worse for the springs and for the public.
Absolutely. Well, unless you have any more final thoughts or anything else to add, I think we're done here.
Good luck. The future. Good luck.
Yeah, thank you. Thank you for being such a wealth of information. That was absolutely incredible.
That's what I do all the time. So
yeah. Really appreciate your time and thank you for the work you're doing. I mean,
glad to help.
Yeah,
glad to help. I don't know that it helps any. I've been saying these things for years.
Like you said, it's like someone has to keep doing it, right? And it's like the world changes through individual action. So it's like whether it's people like you doing science on the ground, it's like, whether it's people kind of raising a ruckus, it's like, we can't just not do anything. You have to try. The only thing you can do.
Good luck.
Yeah, right.
People run out of energy, but I haven't yet. And I'm glad to be continuing it and fighting the good battle. And my life is pleasant because of the people that I get to work with.
Absolutely.
The people that are doing similar things to what I'm doing.
This field definitely has a funny way of kind of chucking pretty wholesome people, I've kind of noticed.
Yeah, it's a fairly small group of people that are fighting these battles. But it's a very interesting group and very admirable people. So I'm happy to be part of that team.
Absolutely. And thank you specifically for your work with Sweetland.
The wetlands?
Well, it's like I'm literally there probably once every 2 weeks. So
oh, that's good.
The fact that you created it, that's pretty cool.
Well, I can't take all the credit for it, but I had a lot to do with it. That's not I keep telling people about it. But so I lead tours and stuff out there occasionally. But it's just so heartwarming, and almost every city in Florida could do that.
Yeah.
And Wetland Solutions, these young men that are working out here, including my son is one of the owners.
Oh, really?
Scott Knight. They're doing treatment wetland projects, and some of the springs funding is going to treatment wetland projects. The Lake City wetland is about the same size as Sweetwater wetlands. It's not open to the public, but it's doing the same thing. Same thing. It's recharging the aquifer with clean water, and that's what we need to do. We shouldn't be purposely putting dirty water into the aquifer.
Well, I'm from St. Petersburg, right? I mean, like this kind of state-of-the-art kind of like treatment center, right? It's like, It just seems like if we just kind of allow nature to do what nature does, right? It's like,
well, you can do it.
Cool.
It takes area to do it. It takes land area, but there's always area around. Orlando ships their water 20 miles to the Orlando wetlands.
Yeah.
It's 10 times bigger than Sweetwater.
Really?
Have you ever been to the Orlando wetlands?
No.
Oh, God, it's incredible. Really? I mean, you have to take a tram around to see it or ride your bicycle.
No way.
It's 1,200 acres.
Wow.
And it was built in 1987. I didn't design that one, but I studied it a lot. I used the data from that and from hundreds of other treatment wetlands to write the book, and then to, obviously work up to the level of designing Sweetwater.
Yeah, if there's a possibility for me to purchase your book, I mean, I would love the opportunity.
Which book?
The one you just wrote.
Oh, the one I just wrote. It's on the Florida Springs Institute website.
See,
yeah, it's for sale there. And then I've got 4 books now. The Silenced Springs was the first one, and it's a comprehensive book about springs issues, but it's from 2015. And then I did one called Death by a Thousand Cuts, which is all like 80 op-eds I wrote over years for Gainesville Sun. And then I did one on Silver Springs with another person down in Ocala. And now this Saving Florida Springs is just a short little one that you can get over at the Springs Institute. I'm sorry I don't have any here.
No worries, yeah. I'll definitely purchase a couple copies. Thank you.
Yeah.
Well, that's it right now.